Hello everyone, thank you very much for watching again. This is lesson number 5, I guess, from our JPA Hibernate fundamental series, and we start our discussion on relationships. So today we will discuss about the first and the easiest of the relationships between entities, which is the one-to-one relationship. Mind that I said entities, so we don't discuss about tables here. Remember, we discuss about ORM frameworks, and I expect that you already know at least the basics of SQL. As I told you, this is a prerequisite. We discussed that at the beginning. Thank you very much for watching. If you are live with me here, remember you can write your comments or questions in the comment section. If you watch the event recorded, you can write the comments in the comment section, in the live chat today, in the comment section afterwards. And of course, you can follow me on Twitter and LinkedIn. With that being said, I don't want to make it too long. I want to share my screen and start the discussion on relationships, about the one-to-one relationship. I have copied the previous example. I have copied it and cleaned it a bit. So I'm starting with the same foundation that you are already used to from the previous lessons. You remember I have told you how to connect to a database and stuff like that in lesson number 1. So I'm not going to repeat this each and every time, to save, of course, your time and to allow you focus on what's essential. I just have like a clean project that simply connects to a database here. Absolutely nothing special in it. It's just our empty foundation. Okay, what is a one-to-one relationship? It's a relationship where two entities are linked, such as an instance of one entity is linked to only one instance of the other entity and the other way around. And a very, very simple example, of course, we can find a lot of examples, but a very simple example that I can use today to demonstrate that is person and passport. So you have a person has only one passport. A passport belongs to only one person. I know in reality there might be cases where a person has multiple passports, but let's, for the simplicity of our case, consider that one person may only have one passport. In that case, that is a one-to-one relationship. Okay, so one person has one passport. A passport belongs to only one person. That makes it a one-to-one relationship. So how would I implement something like that? I will define my entities. I'm starting with the person, and to be an entity, I have to mark it as an entity using the entity annotation. As you have already learned in the previous lessons, you know that it's complaining here because I don't have an ID. The ID we discussed again in the previous lessons is mandatory. Oops, sorry for that. So let's say our ID is an int. To make it a real ID, I have to use the ID annotation, and of course, not mandatory, but if I want, I can use a generator or a generation strategy, which is what we discussed in the previous lesson, where we discussed about generation strategies and how to create your custom generator. I showed you how to create a UUID generator, which is a little bit more particular than the one that is default provided by Hibernate. Cool. So let's say I also have a name, so my person has a name as well, and that's it. Because I want to make it as simple as possible, I'm gonna fill everything with getters and setters, and then I'm gonna step into the second entity. No, the second entity is the password, the passport. So passport, to make this an entity, needs to use the entity annotation, the same thing, remember. So we have to have an ID. I will mark it with the ID annotation, and I'm using again the strategy identity, which allows the DBMS give me self-incremented values. All these things, they have been already discussed in the previous lesson, so that's why I'm stepping fast over them, because I don't want to lose your time. But in case you need a refresher, or if you are here for the first time, then remember you have a few lessons that you have missed, so you might want to watch them first. So private string, say the passport also has a number, and then of course I will end up with the getters and setters. How do I implement the relationship. How do I say that the person has a passport or the passport belongs to one person? In JPA relationships, we have two kinds of relationships. We classify them in one-directional relationships and bi-directional relationships. It is a one-directional relationship in case only one entity knows about the other. So you might say that the person has a passport, but you store nowhere in the passport the information about to which person that passport belongs. This would be a one-directional relationship. Or you can say that the passport belongs to a person, but you don't have any information in the person instance about what is their passport. If it's only from one direction, we call it one-directional relationship, and that's the first we will gonna demonstrate. Let's say that the person knows about their passport, but the passport instance doesn't know about the person. That would be a one-directional relationship, a one-directional one-to-one relationship from the person's side. So you might say something like private passport, and then whenever you have an object, you will see that my IntelliJ complains here. The reason it complains is that being on a basic type, it knows it can't match to a database. You have to make something, you have to do something about it. And that something is specified. This entity is actually what relationship. If you don't do that, Hibernate will complain, or your JPA implementation in general will complain, no, because you can't have that information in one column. So you explicitly need to say, hey, what's the table to which your JPA implementation needs to create the relationship, and what kind of relationship that is. So you have to add one of the annotations we start learning today, and the one we discussed today is one-to-one, which is the annotation you use in case you implement a one-to-one relationship. So that's basically it. And if I did that, I can already say, of course, I still have to define a getter in the setter, but I can already say that I made my best and already implemented the one-to-one relationship, and we will demonstrate now how to create these objects. So I will just try to implement some code to store them. A question in the chat says, what is the purpose of flush after the persist or merge? Very good question. Whenever we use flush, which I remember, yes, indeed, we didn't discuss, is just like saying, hey, please mirror now the context. Remember that we discussed in the beginning that at the end of the transaction is when the context is mirrored. Well, if you use flush, it's just a way you can imagine to tell your JPA implementation, don't wait till the commit. Try to mirror it now, and then you can continue the transaction. Then of course it will again have to be mirrored, but the context and the differences will be different. So if you want to say, hey, persist this now, you put a flush after the persist, for example. Cool. I'm actually gonna persist something as well. So I'm gonna write here, so person p. I will say person because both passport and person share the same first letter. No, it will be then difficult to name them. So say person, which person has a name. I don't have to fit in the ID because the ID is auto incremented. And then I have the passport instance, and then I say passport number ABC123, and then very important, person set passport. So we really need to create the relationship between the instances. That's a must. And then what's really important again is that you have to persist both of them. So if I only say persist person, for example, that won't work, because by default, there's, even if the passport, you would see it as part of the person now, no? Because it's an attribute inside the person. By default, the passport will not be operated with, our operation being persist in that case. So the first option I will teach you is persist both of them, both the password and the person. Sometimes students of mine ask me, is that important? What is the order in which you put the persist? Well, the answer is no, because remember, the persist is not an insert. So sometimes students think about, hey, if I push the passport before the after the person, would that mean that when the person is created, it doesn't have a passport? No, because remember, persist is not an insert. Persist is just putting the reference of that specific entity in the context. The real inserts will happen at this line 42 in my case, which is the commit of the transaction, or in case of course, in case of a flush. At the moment, the context is flushed, meaning it's mirrored to a database like on purpose. So the order in which you store the reference in the context is irrelevant, because anyway the inserts will happen after this. Okay, so you can put them in any order, it's irrelevant, it will have the same result. So let me try to run this now and see what happens. I might have missed something, so it will not work, because remember, we have to specify the managed classes. So passport and person, yeah, it gave me an exception, because of course it doesn't know the classes. Remember, the managed classes have to be intercepted with Java reflection. With frameworks like Spring, this happen out of the box, but when I have a vanilla project like mine, and I don't use an application framework, then I have to specify them myself. No, so passport and person. Okay, so now it should work that I have mentioned them. You've seen this also in the previous lessons. Now we have already dealt with this problem. So let's run again and see what happens. By the way, do I have here specified I want it create the tables? Yes, I did that. And do you see the queries? Yes, here they are, the queries. Was this demo person doesn't exist? I have no idea why, because it says it looks like it's because it tries to probably to delete it first. Anyway, it doesn't matter. You can see it actually created everything, no? And you can see the inserts having created, and then it updated. This is a specific characteristic when you have a unidirectional relationship, but we will talk about this later. But anyway, the result in the database, let me refresh the table and see. We have the two tables, and we have the passport. Okay, the two characteristics, the ID and the number of the password, so the primary key and the number that we have chosen. And you see that the relationship is created as we expect based on the primary key of the password. So it's normally using a foreign key, as we call it. No, it creates it via a foreign key. The name of the foreign key is given by default as passport underscore primary key, but if you want to change that, you will often see, like, not always, we don't always use that convention, the same convention that Hibernate uses. So that's why sometimes you will see people using the join column annotation, and then they specify a specific name, say a password. I don't know what's wrong with me today. So it's passport. Okay, so it's, if I don't want it to be named passport underscore ID, I want to change the name of the foreign key, then I can use the join column. Don't make a confusion between column and join column. Join column is specifically an annotation we use on relationships. Okay, so this one, it's called join column because that's what you do with foreign keys. Now you join, you use joins. If you know the basic of SQL, and you should for this course, you probably know what I mean. And if I'm running this again, we should see that now it uses the suggested name. So when we want to adapt our code to specific values, then this is the way. So let me refresh it again, probably have to close these tabs, going back to the person, and we should see that the name changed to passport instead of passport ID, which is precisely what we expected. And the same thing you can do the other way around. So I could have, instead of having a relationship between the person with the passport, you see the passport doesn't know anything about the person. Only the person knows about the passport. So that's why it's called one-directional. It's only from the direction of the person instead of being from both directions, no? And you will ask me, okay, what's the point here? Can you is something that you can't do maybe if you don't have the relationship in the passport as well? And the answer is yes. So whenever we choose to use a one-directional relationship, I know we didn't discuss queries, but I will show you a little bit of it now, and in one of the next lessons we will discuss more about JPQL, but I want to explain properly up to the end one-directional versus the bi-directional relationship that you will see next. So when you create a query with Hibernate, you know you will always use the entity manager for any operation, because we already discussed the entity manager, and you know that the entity manager is the manager of the context. Is that create query annotation. So the create query annotation receives a string which is the query. You will see that the query is written using a language specific to JPA. We call it JPQL. Again, if you don't properly understand this now, it's not a problem, because it's something I will take in detail in one of the next lessons anyway. But say you want to write a query. So I want to retrieve a person. Okay, this thing gives me a typed query. That's how it's called. So it's the type query for the entity person. Let's call it Q. And then the query is select person from person P where, and if I want now to add a condition on the passport, see that I can intelligent smart enough and shows me what I can do, and that's also good for you, because you can see that what I'm telling you is correct. So I can say where passport number is some numbers. So something like this I can say, and I can prove that's working. So say set parameter for for number value ABC123. Okay, and then I can say get result list and print the entire result list in the console to prove my point. And of course, if you want to really see something, maybe it's a good choice that I also override the toString method, and here it is. So if I'm running this now, this query works, and the reason it works is because there is a passport reference in the person. Now imagine the other way around. With the same setup, can I write a query where I want the opposite, to get the passport of a person given the name of the person? Can I write something like that? No. The reason I can't write such a query, the reason why such a query would be not runnable, is because the passport doesn't have a relationship with the person. So it's only from the person direction. It's one direction relationship. Okay, so when do we choose if we have one direction or the other? That's the question probably you need an answer for, is depending on the queries that we write. If you know that queries that you write are from the person direction, then you have to have the relationship in the person. If you know that the queries are from the passport direction, then you have to do it the other way around, and the owner of the relationship should be the passport and not the person. By the way, wherever we have the relationship and the join column is also where we call that entity the owner of the relationship. If you want to have the possibility to do that from both directions, then you do it with a bi-directional relationship. So if you want to be able to work with both directions, then you can do that. You can have attributes in both directions. So what I would do is something like private person, and then I add the one-to-one annotation. And remember, always on the opposite side of the relationship, or on the opposite side of the owner of the relationship, you have to add the mapped by attribute, where you have to specify the name of the field to which this person is mapped. Of course, I have to add now getters and setters. Here they are. and you can still keep the join column. That's good. You can you may not have it. It depends on whether you want to use the default naming, that one with underscore or not, but you may skip it. But anyway, it keeps the same rule. You must remember always the join column is on the owner of the relationship. The owner of the relationship is also where in the table there will be the foreign key, and on the opposite side of the relationship you have to add the mapped by attribute. Going back to the main, if I want now to store this again, then what I need to do is I need to make sure that both the passport and the person have relationship one with the other. So it's not enough to go only from the person's side anymore. And you might test this and you might see that in some cases it works, but it's not recommended. So it's not guaranteed. That's but what I know from the specification doesn't guarantee you that if you don't properly define the bi-directional relationship in your context, that this will work. So that's why it's really important to be sure that both sides properly link to each other, like I did here. And of course you can now run, and what this solves is now it's as you can see, it added some complexity. So that's why most likely you would prefer to avoid the bidirectional relationship if you don't need it, but at the same time it now gave you the possibility for querying from both directions. No, so that's the point as well. In terms of the persist, I started telling you that you need to persist both instances, but I also told you at the beginning of our discussion today that you have also other options. So which are the other options? The other option is called cascading. I want you, however, to be very careful with cascading, because sometimes it's overused. I would say it's abused. And what cascading is you want to always, when you apply an operation to a specific instance, to apply it to other entities or other entity instances, better said. You want the same to be applied to other instances. So instead of having to manually say, hey, I want to persist the passport as well, you want to say, I want to persist the person. And if the person has a passport, I want to persist that as well, without me explicitly persisting the passport. If you want to do that, you do it through cascading. Cascading is done using the cascade attribute on the relationship annotation one-to-one in our case. And you have multiple options for the values you provide to the cascade attribute, which you would recognize, hopefully, as being the operations we discussed in the previous lessons. If you were here with me in the previous lessons, we discussed about persist, merge, detach, refresh, and remove. These are all values, names of methods from the entity manager that we discussed in the previous lessons. I would recommend you, if you need a refresher, go back to the previous lessons and remember how they work. So refresh, remove, persist, merge, and so on. They are operations, all of them operations of the entity manager. So what this cascading does, it says, hey, please cascade this operation if ever done on the current instance to this specific attribute. So if the person is persisted, then the passport should also be persisted. And you can have as many operations as you want cascaded. So you can say cascade persist and cascade refresh as well. You have to choose which operations you want to be cascaded. And there is even a possibility to say cascade all the operations. So regardless of what operation has been done on the person instance, please do it as well on the passport. But mind that it's not recommended to use all. Actually, a good practice is to always restrict the cascading to precisely your case, what your case wants. One of the biggest mistakes I see with beginners with ORMs, and especially with JPA and Hibernate, is using the cascade all like hell. Anything that happens should happen to the child as well. The problem with that is that it creates a lot of post-testing possibilities, and you're pretty sure will not test everything, and you basically give too much flexibility, which in the end might end up with unexpected behavior. So don't leave things too flexible. Don't cascade all if that's not exactly what's needed. If you only need a persist operation, just use the persist operation. If you only want the remove operation to be cascaded, then use the remove. If you want both the persist and the remove, put both of them in an array as value of the cascade, but only those, because only those are the operations that you want to be cascaded. So that's a best practice that you need to remember and to apply about cascading. So cascading now, of course, allows you to save a lot of code, because in real world you would have to persist maybe in multiple locations, and you don't have now to have one more line to add, for example, or potentially more lines if we discuss about more attributes. But be very careful, and remember, be always aware about everything you cascade. Be aware of them, know that they are cascaded, and understand the implications of that. Okay, in my case here, of course, only adding this cascade persist would just make that the passport is persisted, even though I don't do that manually. So I didn't have to add this anymore. I'm just writing persist person, and then because the person is cascading the persist operation, the passport not existing yet will be as well persisted. So see, that's how it works. One other attribute that is maybe important, relevant to discuss, is the fetch. We will go more into details with the fetch when we discuss about collections, because that's where you will be really interested in this fetch. It might create difficulties, and I will teach you how to avoid the difficulties. But one of the things that you can remember is that the fetch of any non-collection, so meaning any simple object, is by default eager, meaning that when you select that person, automatically details about the passport will be selected as well. So you don't have to do anything about it. Automatically the details will be joined and selected. Say you don't want that. If you don't want that to happen explicitly, then you can use the fetch lazy, so that only when the passport is used the first time, then the details about the passport will be fetched. You don't use the details of the passport, then they will not be fetched. So this is kind of postponing a part of the operations, but you have to be very careful with that. Again, I will discuss more about fetching when we take the subject in detail with collections, but remember that's not like something that will necessarily improve anything about how this works, because it might be faster to fetch them eagerly, which is the default, yeah, because you anyway have only one join, so you send only one query, grab all the data. It's a little bit more data. It's a little bit a more complex query, because it will be a query having a join, but you send it only once, grab the data once, have the instances in the context, and then reuse them wherever you need. If you choose for the fetch type lazy, then initially only the person values will be taken, which means one query will be sent. It will be not joined, so the join will disappear, no? Because that's what we get by using the lazy. We get the data, but then if you use the passport, another query will be sent to retrieve the data about the passport. So you avoided the join and transferring more data at once, but you sent two queries, which, remember, inputs and outputs are tricky always. They are the ones who are usually creating performance difficulties. So it might not be that necessarily using lazy helps you. And to be honest, the reason why the fetch is eager by default with simple types is because in most cases it's more performant to keep them like that, to keep them eager, okay? But think about it. Remember, this is an important concept, the fetch, and again, I will take it again when the time comes. What other attributes you see here? Target entity is a very old one. You don't even need to know it anymore. In the target entity is where you want to create something like the relationship based on a type that is not the actual type, but maybe a super type like object. In that case, Hibernate would not know what type the object is, and you will have to explicitly provide it through the annotation. It's something that you will only see in very ugly and old legacy code, so I will not bother talking a lot about this target entity anymore. Optional, which makes this value optional, is only if the database allowed that column to be null. And remember, whenever we discuss about relationships, you might have a relationship where the cardinality is 0 or more, which means that you might have a situation where the person might not have a passport. If you want to be able to have a person that might not have a passport, then you want to make this optional. If the relationship is mandatory, so the person should always have a passport, then you need to have it false here. And of course, this depends on your business logic. If you are writing code for an application where for one of the gates at the airport, where the person has to put their passport, then the person will always have a passport, because you can't have interacted with the gate if you don't have a passport. So in that case, the optional here might become false to make it a little bit more restrictive, and you might say you enforce the relationship. The person will always have a passport. But of course, the default is true, so meaning by default null is allowed. So you might have, in that case, the way I wrote the code using the default, you might have the person that doesn't have a passport. We already discussed the map by, so I'm stepping over it, and the orphan removal is a constraint where you want to allow the child of an entity remain in the database even if the parent has been removed. This might be related to one of the questions that I see in chat now, the soft delete. So let me take that when I discuss that, because it's a little bit trickier. As an idea, it's not an attribute that you will see often. I would not even recommend. Usually when you see it, it might be something fishy about the design there, so I kind of try to avoid using it where that's not the case. But yeah, it's there, and I wanted to show it to you as well. I see another question which is good or bad to write named queries above the entity? Let me take this answer in one of the next lessons, please, because we will discuss about named queries. I haven't even discussed. I know today I used typed queries, and I didn't tell you anything about what I wrote here. but that's something I will take in details in one of the next lessons, so you don't have to worry about that. I will answer your question at a time so that I can answer it in a detailed way with all the good and bad things about name queries, because name queries are not evil. But depending on what your app does, you might want to use them or not, and I will explain you at that time what and when. So this is basically it, you see. So I told you, I would say that everything you need to know about these relationships, so you have seen how they work. Now I want to enforce something. Remember that when you talk about relationships here, when we say one-to-one, and of course in the future lessons we'll discuss about one-to-many and many-to-many, we discuss about objects. Sometimes there are relationships at the database level between tables that will not be reflected in relationships among objects. And this is something that beginners with ORM frameworks think as being, wow, crazy, no? How can it be that I have a relationship in the database but not between objects? Because not always all the tables in the database are entities. One of the best examples being the join table. If you know the SQL basics, you know that two tables in the database that need to have many-to-many relationship in terms of entities, they will use a join table to establish the many-to-many relationship. That table, that third table, it will not have an entity attached. I know we will discuss many-to-many relationships in one of the next lessons, but I want to give you an example. Today, however, I will give you a second example which is a lot more rarely encountered, less often encountered than the join table, but which represents within a one-to-one relationship in the database, not a one-to-one relationship in the application. And this is the secondary table. If you have never heard about a secondary table, this is a specific situation that happens usually only with legacy databases, where you have multiple attributes segregated in multiple tables. So say for example someone in the database, when they created the database design, they said, hey, I have a table users, and that table users is my entity. No, it has an ID. It has an ID. Okay, and it has a name, and it has many other things but we don't care about those. I just want to like have the minimum so you can focus on. But then on a second table, what they did is that they added something like description. So for you, the description of the user is still an attribute of the user. So you want it as part of the entity here, no? But in the database, instead of being part of the user table, someone, the way they created the data model, it's segregated into another table called, let's say, user details. So what do I do in that case? In that case, I will mention that this entity is segregated into multiple tables. Actually, I will give you an example with two now, but remember that you can have more than two. However, even with two, it's not really a desired design. It's not really a best practice, but I can't promise you that it won't happen to you with especially legacy code to find situations like that. But this is a good opportunity actually for you to remember that not all the relationships between tables in the database are also relationships in between objects in a JPA implementation. This is, and that's why I will continue repeating throughout the whole lessons. You've heard me in the previous lessons, and I continue saying it because it's very important. Relationships and the way of thinking in general with these kinds of frameworks is object related. That's why this is called an object relational mapping framework, no? Because the object is the key entity. So what I can do here, I say, hey, this is in the table called user details, and then I also have to give it the foreign key relationship somehow. What is the link between? And then I do that using this primary key column, where I say, oh, sorry for that. This primary key column annotation. Okay. Oh, something happens today. Primary key column annotation. Okay, with, and then you have to specify the name. And I don't know. I can even call it ID or user or whatever you want. You might even have, but I'm not going to go into so many details because it's not that relevant. You would learn this for nothing. But you could even have a composed primary key here. That's why when I typed, you saw that I selected the primary key join column annotation, but you might have observed that there is also a primary key join columns annotation, meaning that you might have a composed primary key to make the relationship between the primary and the secondary table. But again, let's keep this soft for the moment. So let me prove what happens now. I'm gonna comment the rest of the code out now, or I can leave it like this anyway. And I say user is new user. And then of course I will put the name of the user, and then I will put the description of the user. And then I would persist it using the entity manager. So I'm persisting the user. And now I'm running everything. And again, I didn't add it, sorry for that. So it will not work unless I also add it here. See what happens when you get used with Spring and other high-level stuff. You always remember that you have to do some things manually when you work with vanilla stuff. So yeah, of course, the exception is accepted. It didn't know what the user is. Now it does. I'm running it again, and then we will take a look in the database to see what happened. What is the best schema for one-to-one table or table per entity? I'm not sure I understand the question. Sorry. You maybe want to say if I want to split or not the details. I'm not sure I understand. But anyway, these details are more like related to how you define the design of a database, and they are depending on what you implement. I don't see this as something which is JPA specific, so I'm not sure if this is the place to discuss this. Maybe I will take that in a separate video. Okay, cool. What happened? So let me see. I'm already refresh all, and you see what happened. We only defined one more entity. However, we got two tables. Why? In the database between the user table and the secondary table, we had this. I also made a mistake, but I'm glad I made the mistake, because I wouldn't be able then to show it to you. So you see that now I have the user details is not correctly created, and the description is now empty. So something must be wrong with what I did, and it is. And the thing is wrong is actually the fact that whenever you do something like this, you also need to specify explicitly which of the attributes are part of the secondary table. Okay, that's why it's not working for me. So I'm gonna say column. This column is in the table user details. Otherwise it will not know what is the table where it will find description, because remember, now our entity is based on multiple. This is what is called the primary one, the secondary one, and I told you might even have more than two. So it has to explicitly being told where exactly is each attribute. So the reason it looked like crap here and I have an empty description is because I didn't define it correctly. So let me now try again. Oh, it looks good. I don't know why these are empty. I did the structure is fine, so the structure is good. Okay, to be honest, I'm not sure why it's this empty. Didn't I persist the person? I persist the user. Yes, I did persist the user for some reason. Set name again. Oh, this is what happens when you are too enthusiastic about what you are saying, and yeah, things happen. So this is basically what we expect. Description. Oh, and here you see the data now. Okay, cool. So this is what we expected. Fine. So you see that's a very interesting thing. This is not a relationship from the JPA point of view, but it is a relationship in the database. From the database point of view, it is a one-to-one relationship between the user and the user details. However, because user details is not actually an entity, but the entity is actually the composition of these two tables, and again, there can be more than two, then at the application level, we defined only one entity, and the relationship doesn't exist because it's one entity. So remember to make a difference when between where you have a one-to-one relationship, so where there literally are two entities in the database, and then you have a one-to-one relationship, like the case of passport and person, or the situation where the relationship is actually just defining the composition of an entity, and then what you use is secondary table. I will leave you with this information now, and of course, as usual, I'm gonna make sure that I'm gonna put everything on my GitHub so that you can also test it. And one more question: one-to-one generate two table passport, and why not generate only one table and bring the other attribute in it? Because if you go by this logic, then you don't have a database with only one table. No, they are logically two different entities. So the passport is a passport. Think about it. No, it's a passport. So if it's a passport, you have it as a passport. It doesn't belong to the person. No, the person is one entity. The passport is something else. They are, even if you think in real life, two different objects. No, so they must be defined as two different tables that specify that they are two different objects. So the reason why we don't put all of them together in this case is most likely because it's the best as a model. Of course, I'm not going to deeper into details, because sometimes maybe you want to merge these kinds of things together for performance purposes, but these are database related stuff, so I don't want to go into database and SQL stuff. That's why I made this a prerequisite of this course, being you need to know already the basics of SQL and databases to follow and to learn Hibernate, of course. What happens if you change the description? Well, if you change the description, it will update in the right table. No, so you can change the description, and then it should simply update most likely. Of course, that means that here, if you want, I should also put a none. So some user, some other user, okay, or other user. Okay, so you change the description, then it should generate an update and change it in the proper table. I will leave you with this now, so I'm gonna just allow you the time to digest this. It's really important to understand properly the one-to-one relationship before we go into the other relationships, because it's the simplest. So till next time, when we'll discuss the one-to-many relationship, or at least we start discussing it, my recommendation is take this example from my GitHub account, try to run it yourself, and try to play a little bit more with it, so that when you are comfortable with the one-to-one relationship, then the next thing you can do is, of course, and that's what we're gonna do together, start discussing about the next relationship, which is the one-to-many relationship. Thank you very much, everyone, for being here with me, and until next time we meet, I'm telling you, have an excellent time for study further. Cheers.